All right, this chapter is going to cover Mod 2, Chapter 3, Functions. So I'm going to create a new Python file. And I'm just going to call it Mod 3, or I'll just say Module 2, Chapter 3, Functions. All right, so first I'm going to start off with a bunch of the pre-built functions. So, if I said int 32, and run this, it's turning your string into 32. Now, you have issues if you have a string and, you try to turn into an int. Can't do that. Can do things like, let's say negative 2.3. Okay, so this turns it into an int. It chops off because an integer is a whole number, it chops off the decimal point. Okay. Let's say if we had something like float 32, which can be 32.0, okay, because it takes the integer 32 and turns it into a float. We've looked at some math.imp. Yeah, let's do this. We could say math, import the math functions. So we could do things like print math.py. Okay, it gives us that. There's other things that we can do with this. We could say something like radians equals 0.7. And we could say math.sine, let's say radians. Run that. Okay, so those are easy ones. So these are all the pre-built ones. Now we're getting to the point where you guys are going to build your own functions. And really the purpose of functions is functions do something. They need to accomplish something. And so it's like code that accomplishes that something. So if you were to build a calculator, you might have like an add function that would add up numbers. So something like this, you could say, this is an example kind of from the book, but if I said print movies, or let's say movie titles, okay, and so this is the header of your function. You're defining a function. It's creating an object called print movie titles, and it has type function, and I'll show that in a minute. But I just saw the movie Endgame, and while I was watching that movie, there was previews for the new Lion King movie. Okay, so if I wanted to get in here and say print print movie titles, okay, let's see here. None's coming up. Okay, anyway, so it's printing our movie titles. Oh, that's why, because it's printing this. All I have to do is say print movie titles. Sorry about that. And we'll just print these two strings in here in the print movie titles function. Now, notice that everything in my function is tabbed over 1. If I do not do that, it should create issues. Yep. So it needs to move over. So in, if you learned on C or C++, or in Java and a lot of language, they start and end functions with opening and closing braces. Okay. Now, if you try doing that here, you get syntax errors. Python has built this to try to get rid of as much syntax as possible. So everything that's tabbed over one belongs to the print movie titles function. This does not belong to it. This is code below it that calls the function. Okay. So let's create another one. Okay, so we can do def, we're defining one, and we'll call it repeat movie titles. Okay, and I forgot to put, that needs to have, again, a colon to indicate to the compiler that it's a function, and this one will print movie titles 2 times. Okay, so now if I say repeat here, what it's doing is this one is calling, so this right here calls this function. So it's reading the code and it sees, oh, I'm calling a function here, so it goes into this function, runs all the code in here, so it prints endgame Lion King. This call to this function is now complete, and it now calls print movie titles again, which goes up here, and then prints endgame and Lion King again. Okay, so that's the, I guess, the flow of how you would want to read through this. Okay, so these don't get called, or they don't run automatically. This is the only line of code that runs automatically, and then it starts calling the function. So when we work on these, you create your functions towards the top of your program, and towards the bottom you're calling your different functions. And you could switch it up. If you wanted this to be on the top, then your functions be on the bottom. That would work too. It's not going to create an error, but I think what Python is looking for is you define your variables at the top, you define your functions, and then you have your code below that calls all the different functions and runs your program. Okay, so the code below is like your user interface, kind of. We're not creating user interfaces in this class, since we're doing everything basically kind of character based, and printing through the output window kind of down here. So anyway, there are different, let's look at this. Functions, let's say if I had define, like I go back to that calculator function I was talking about. We have an A and a B. So let's say we just we're creating a simple calculator, and we could say total equals A plus B. All right, and let's see here. If I wanted to say add, and I could say right here, I could say, how do I want to do this? I could say, 5,3, and let's say I wanted to print this inside here. I could print total. Okay, so these are called parameters. All right, so I can call my function add, and I'm passing in 5 right here, and A gets set to 5, and then I pass in 3, and b gets set to 3. And so 5 plus 3 is 8, and it just prints that. Okay, and I could do other things too. I could say define subtract, and I could say a and b here, so it's accepting an a and a b. I could say total equals a minus b. Okay, and let's change this one to subtract, and it should give me 2 here. Okay, so same thing here, 5 gets passed into subtract, and so a is now 5, and 3 gets passed into, and it's set to b, and so b is now 3, 5 minus 3 is 2, and it prints that to the screen. Now, one thing that gets a little bit confusing is something called scope. So let's kind of look at this real quick. So let's say I had total equals 0, okay, and let's change a little bit of this up. Control C that, and say print total. And let's do something else that we can do. I could say num1 equals 5, and num2 equals 3, and I would change these to num1 and num2. So now when I do this, num1 is 5, and it gets passed in, and a is now set to num1, which is 5, and num2, b is set to num2, and that's 3. Okay, but right here total is 0. If I run this, I get total equal to 0, even though look at what we did here. So this is an issue with scope. This is calling basically, or it's printing this total, okay? So this is out of the scope of this total right here. So you're gonna want to fix that, and there's a lot of different ways you could do that. So instead of defining total as 0 right here, we could say total is a global value, global total, and that's equal to 0 here. All right, so if I run this now, let's see here, let me just do that. Okay, now my total has a global scope, and it will go across the different functions and outside of it. Okay, a better way that I would go about this would be to use return functions, and I think your book calls it fruitful functions. I don't like fruitful functions at all. I always call my functions mutator, and this goes back to Java. Mutator methods, I'd call it a mutator function or an accessor function. So the mutator function changes something, so there's a calculation in it. An access function would return information. So it's accessing the information. I like it being called access better than fruitful. I don't get how fruitful has anything to do with return functions. But anyway, the way I would actually write this out is I would get rid of this, and I would say up here total could be equal to 0. Okay, and then you could do total equals a plus b, and then you can return the total. Okay, and so it runs your calculation like normal, and then it's returning this value. And there's a couple ways you could do it. You could say print this. Okay, and so now you get 8 here, because what's happening is you're calculating total, and then total is being returned right here. So total is returned, and it prints 8. Okay, so you could do it like that, or you could say total, total equals this right here, and then you could say print total. Okay, and that should still be 8 once I get rid of that. Okay, so what's happening here, you're calling add with the variables that you have. It's adding up total. Total is being returned, and then it's being stored in this total variable right here. And so that gets around the scope issue. So that shouldn't be a big problem, but try playing with that. I don't think the return methods pop up in your book for another couple chapters, but it's something to look at right now, and it might help you with some of your stuff. So next section is why functions. So there's a bunch of reasons. Like I said, functions are used to basically put like data together. Yeah, fruitful functions. Anyway. So, I mean, even in the book, it says some of the functions we have used, such as the math function return results. For a lack of better name, I call them fruitful functions. I don't know if you're going to hear that anywhere in industry, so I'd call them accessor functions or mutator, changing them, meaning nothing's being returned in mutator functions, but accessor functions, something is being returned. So why functions? Well, like I told you, with like the add method, you're adding up variables in your calculator. You could have a subtract function, minus function. One of the big reasons for doing this is that it busts up your code into smaller pieces, so that if those smaller pieces change, you just change one piece of the function, and it doesn't like completely mess with the rest of the program that you're building. At the same time, in industry, when they're working on massive, programs, thousands of lines long, you can break up tasks to different people and say, okay, you do this function, you do this function, and you do this function, and we'll come back together, and then our functions get plugged in to our main program. And so it makes it easy to delegate tasks. What is it saying? Create a new function gives you an opportunity to name a group of statements, which makes your program easier to read and debug. So, this was a big change from procedural programming back in the day, where programs were just giant, programs going line by line by line by line, to what's now called, in its industry standard now, object-oriented programming, where you create an object and that object calls to different functions in your class. So it divides a long program into functions, allows you to debug, so you're debugging smaller pieces instead of the entire huge program. You can eliminate code. So this is the whole part of reusability. If you build a function that works properly, you can use it in all of your different programs instead of having to write code for the same code inside every single program. That becomes a real pain. So a big thing with object-oriented programming is reusability. Let's do this. The next thing, I don't know if this is in the chapter, but well, maybe. Let's see. It's 3- I'm going to do the exercises. So it says, write a function named write_justify that makes a string named s as a parameter and prints the string with enough leading spaces so that the last letter of the string is in column 70 of the display. So let's see here. First things first, and they haven't taught you this, is there's a function called len. It looks like this. And what len does is it returns the length of your string. So if I had a string s equals, my name's Mike, and I passed s into it, let's say print. Okay, that's the length of this is 1, 2, 3, 4. So it gives me 4, right? So in that program, it wants you to print blank spaces, and it wants your word to always start at position 70. Right. Okay, so once we know this, this becomes pretty easy, because what we can do is we can say define right justify. We're passing in s, and we can print blank spaces for a total of 70 minus the length len s, and then we just add s to the end of the string. Okay, so I can say right underscore justify, and I think it had Monty as the name. Okay, so there's my blank spaces that it's printing, and if I went through and counted them, it would be, you know, the proper amount. So that's exercise 3-1, and let's look at 3-2. Well, 3.14, I guess it's called. Exercise 2. Now I'm not going to do exercise 3. There's an answer in here, and I'm just not going to do it. This is way too repetitive in my mind, and to be honest, way too much to. There's way too many functions that are called that are embedded within functions. And if I was going to print this up, I would just use what's it called? I would figure out a way to use loops in this. I wouldn't do it like this. It's just too difficult. This one also has answers, but I can kind of go through it. It says type this example into a script and test it. So example do twice. Okay, so let's just type this stuff in. Okay. And now when you guys are learning this stuff, though, I mean, programming is kind of it's like a contact sport. If you're not typing this stuff in and seeing how it works, you're not going to learn it. Okay, and that's just me. I'm warning you right now. It's not a class that you can just sit and memorize like a history class, like dates or something like that, or concepts. If you're not programming, you're not going to learn how to do it. So anyway, for this, let's see what it does. This doesn't look right to me. Let's run it. Spam. Okay, cool. So anyway, do twice calls this one right here, right? And it passes in print spam, which is F. Okay, so this is really print spam. Okay, so it calls print spam and print spam, and then this print spam calls this one, and it prints it. Okay, so to modify do twice so that it takes 2 arguments, a function object and a value, and calls the function twice. Takes a function and passing the value as an argument. Okay. All right, so we're gonna have do twice, which will have F, comma, and then the word. All right, and it will pass the word in to here. Okay, and we're going to print the word, and we'll say print spam, comma, word. And what do we want to call our word? Word I don't know, help. Okay, so help is going to be passed in here. We've got print spam. Okay, that's going to call this guy right here. No, sorry, do twice is going to be F right here, which is print spam. It's going to pass in the word, which is help, into here, and it's going to print the word help. So let's do that. What does it say? Word is not defined. Let's see here. Help. Wait a second. Equals help. Alright, I think I figured it out. I gotta put word right there. Try to run this. Okay, so again, do twice gets called right here. It gets passed print spam, and word gets passed in, which is help. So print spam calls here and passes word. I didn't have that right there, so it was going up. We don't know what word is, but since word is passed into here, it prints there, and then it prints spams again right here and passes help in, and so it prints again. Okay, so next up, part 3. Copy the definition of print twice from earlier in this chapter to your script. Okay, so I wrote that down. So what do we got here? Print twice. So let's say we had writing more general, print twice that takes a string as a parameter. Okay, so let's do this. I'm just going to say string equals, I'll say help again. Okay, and I'll say define print twice that receives the string. And I can say print string, print string. I can say print underscore twice the string. Okay, and so that, you know, print twice gets called, passes in the string, which is help. Excuse me. Then I print the string twice. Okay. 4. Use the modified version of do twice to call print twice, passing spam as the argument. Okay, so let's call the new word, we'll call it spam. Okay, and we could say do twice print underscore twice new word. So do twice and probably want to go back and add in my define do twice with my F comma word, F word, so look at this. It should. So print twice, sorry, do twice calls this, which is F is print twice, so that gets called, right? And the word spam, new word spam, gets passed in here, so it's now word, and so it calls this and it prints it twice. and then that prints twice. So that's that. All right, let's see here. What's the last one? Last one, 5. Define a new function called do4. Takes a function object and a value and calls the function 4 times, passing the value as a parameter. There should be only 2 statements in the body of this function, not 4. So if we know that do twice prints this twice, then we could do define do 4, which takes f and word, same like the other ones, and you could say do underscore twice f comma word, and let's see here, I think that's right, do underscore twice f comma word. You would say do 4. I think this is good. So then, yeah, 1, 2, 3, 4, 5, 6, 7, 8. So that's 8. So there's 4. I just commented that out. So, so that's basically, you know, functions. As long as you guys are able to create a function, call a function, pass parameters between them, and be able to run through the flow of it, this chapter should be pretty easy. Like I said, if you guys want to play around and kind of figure out this exercise 3, go for it. But in my mind, it's it's overkill, and I don't think anybody would create the program like this. Again, they would use a loop to check and see what line you are on, and if you were on one of the lines that printed like this, you would print that, and if you were on every other line, you would print like this. So let me think about this. Would be 0, be 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. What would I do? I'd probably do yeah, I would just do I would definitely use 4 loops to run through this. I would not do this code, but anyway, go ahead, try if you want.